Okay, so we've got triangle RST. So we're going to draw ourselves a triangle. We don't know if it's going to be to scale or not yet. SR is greater than ST, so let's just pick a side length. SR is, let's call it 10, and it's greater than ST, so let's call it 9. And ST is greater than RT, so why don't we just go down by 1 again? So that's 8. If one of the angles is obtuse, which angle must it be? Isn't that the same thing as just asking which angle is the largest, right? Because a triangle can only have one obtuse angle. And so whichever one's the largest, if one of them is going to be obtuse, that's the only candidate to be the largest candidate to be obtuse. So we would find the longest side, and across from the longest side would be the largest angle. So I hope you got angle T as your answer. Angle RTS, angle T. The next one says, if one of the angles is obtuse and one of the others is 60, which angle is 60? This one takes a little bit more thought. So if one of them's obtuse and one of them is 60, what would the last angle be? Greater than 60 or less than 60? So we agree that T is obtuse. So I'm going to redraw my triangle, R, S, T, and let's make it obtuse. Let's make it, I don't know, you want to make it 100? If that's 100, and then one of the angles is 60, then 180 minus 160, the remaining angle would have to be acute, right? No matter which obtuse angle, even if I picked 90.01, still, when I add that to 60 and subtract from 180, I definitely have an acute angle on my hands, no matter what. So the angle that would be 60, let's see, this one's still 10, this one's 9, this one's 8. So the angle that would be 60, it would be the middle angle. The middle angle is going to be across from the middle side. So the side that was the middle in length would be across from the 60. So which angle is 60? It would have to be angle R. Here are the answers to your special segments homework. Okay, I can work number 7. Yes, Graham, that's fine. Okay, working number 7 and number 9. Anything else? Yes, it is. Yes. Every time, on number 7, every time we tell you what kind of segment, what kind of special segment we have, you must add markings to your picture. Every segment has certain markings that it goes with. So on number 7, AD is an altitude. So for an altitude, you would add 90-degree angles, because an altitude is the segment from a vertex to the line containing the opposite side, perpendicular. So what I would do to start this problem is 4x plus 10 equals 90. You would not set 2x equal to 3x minus 4. Nope, because an altitude is not a median, unless it's isosceles. Okay, so you would subtract 10 from both sides. 4x equals 80. X is, nope, not 20. Hello. Yes, 20. Wow. X is 20. And so we would take that value and we would plug it in. We're trying to find BC. So 2 times 20 is 40. 3 times 20 is 60. 60 minus 4, 56. And then we would add them together. The distance from B to C is 96. Is that okay? Number 8. Is that? Well, oh, number 9. Number 9. Draw a triangle ABC, then draw the following. Okay. So draw a triangle ABC and then draw the following. Draw the altitude from A. So I would need to try to make a 90-degree angle, a segment that reaches the opposite side that is perpendicular to the opposite side. So that's maybe not perfect, but close enough. So I did the altitude from angle A. the median from angle C, median, midpoint, the perpendicular bisector of BC. So I would go to BC, I would find the midpoint, I would put tick mark, and then I would do that. The perpendicular bisector doesn't go through a vertex unless it's isosceles or equilateral. And then the angle bisector of B. So take this, draw a ray, and arc. So that's a very messy picture, but that's how you would do each one of those. So for each word, there's certain symbols that you add. For an altitude, you add 90-degree angle marking. For median, you add tick marks. For perpendicular bisector, you add 90 degrees and tick marks. And then for angle bisector, you add arc